There's a wall that heats your home in winter and cools it in summer without a furnace, without an air conditioner, and without a single dollar of electricity. Not a smart wall, not a high-tech wall, a wall made of concrete, black paint, and glass. That is the entire system. The materials cost less than $200. The physics behind it have been understood for over 2,000 years. The Roman Empire used a version of this in their bathhouses. French engineers perfected it in the 1960s. NASA studied it for off-planet habitat design. A single wall can reduce your home heating bill by up to 70%. Permanently, not this winter, every winter. For the rest of the building's life, no fuel, no maintenance, no monthly invoice. You build it once, and the sun does the rest forever. Then, someone at a utility company did the math. The global HVAC industry generates over $240 billion every year. U.S. residential electricity bills total more than $150 billion annually. A wall that eliminates the need for equipment is not a product to sell. It is a revenue stream to destroy. They did not stop using it because it failed. They stopped talking about it because it worked too well. This is the story of the Trombe Wall, the passive solar system that empires used and energy companies buried. Welcome to Fixvival. The subscribe button and the bell are the only way to make sure this knowledge survives. Here, we open the vaults the industry locked shut. Now let me take you back to where this all begins. The year is approximately 100 AD. In the southern provinces of the Roman Empire, architects face an engineering problem familiar to any homeowner today. How do you heat a large stone building through a long winter without burning so much fuel that the cost becomes unsustainable? The Roman solution was not a furnace, it was a wall. Specifically, a south-facing wall built from dense stone or fired brick. It was positioned behind a thin layer of translucent mica sheeting that acted as a primitive form of glazing. During the day, sunlight passed through the mica and struck the dark stone wall directly. The stone absorbed heat all day long. Then as the sun went down and temperatures dropped, the wall slowly released that stored heat back into the interior throughout the night. Roman architects called this principle opus cementitium solaris, the solar cement work. Vitruvius, the Roman military engineer whose architectural writings survived, described south-facing thermal walls in his treatise De Architectura. They were essential design elements for any building meant to remain habitable through cold seasons without excessive fuel consumption. That is a Roman engineering manual describing passive solar thermal mass, written around 15 BC. The principle is that old, but Rome was not alone. In the cliff dwellings of the ancestral Puebloans in the American Southwest, builders used south-facing canyon walls. The masonry absorbed solar radiation all day and radiated warmth through the night. Archaeologists studying Pueblo Bonito found thermal mass wall design so sophisticated that interior temperatures remained stable within a 10-degree range. This was even as exterior temperatures swung by 50 degrees between day and night. These were not primitive builders guessing. In the medieval Islamic world, architects in Persia developed wind catchers and thermal mass wall combinations that worked in both directions. The same dense wall that captured solar heat in winter could be shielded in summer, acting as a cooling sink. Now, fast forward to 1881, Edward Morse files a patent for a solar heat storage wall, precisely documenting the thermodynamics. The principle is not about adding heat or removing it. It is about controlling the rate at which a building exchanges thermal energy. And then it sat completely ignored for 80 years because cheap coal and natural gas made thermal efficiency an afterthought. But in 1967, Felix Trombe was working in the French Pyrenees, needing to heat a research station where fuel was expensive. He built the first modern demonstration of the system at the CNRS Solar House in Odelo, France in 1967. The structure maintained interior temperatures between 18 and 22 degrees Celsius throughout an alpine winter, using no fuel source whatsoever, zero fuel. The sun hit the wall during the day, the wall held the heat, the wall released it at night. Felix Trombe published his findings, and his name became attached to the system permanently, the Trombe Wall. Let me explain exactly why this works, because the physics is elegant enough that once you understand it, you will never look at your heating bill the same way again. Every material on Earth has a property called thermal mass. This is its ability to absorb heat energy, store it, and release it slowly over time. Water has very high thermal mass. Air has almost none. Concrete, brick, stone, and adobe sit in a very useful middle range. They absorb heat relatively quickly when exposed to a heat source, but they release it slowly over hours. This time delay is the entire secret of the Trombe Wall. Here's the complete system broken down into 3 phases. Phase 1 is absorption. The south-facing exterior surface of the wall is painted matte black or coated in a selective absorber material. Black surfaces absorb approximately 95% of solar radiation that strikes them. A single pane of glass or polycarbonate glazing is mounted a few inches in front of the black wall surface, creating a narrow air gap. Sunlight passes through the glass, strikes the black wall, and converts to heat. The glass then acts as a one-way thermal trap. Infrared heat radiation emitted by the warm wall cannot pass back through the glass as easily as the incoming solar radiation could pass in. This is the greenhouse effect operating at the scale of a single wall. Phase 2 is storage. As the sun moves through the sky over 6 to 8 hours, the outer surface of the Trombe Wall reaches temperatures between 50 and 70 degrees Celsius. The heat conducts slowly inward through the mass of the wall. A wall made of 20 to 40 centimeters of concrete has a thermal lag. This means that heat absorbed at noon does not reach the interior surface until 8 to 12 hours later, which is precisely when you need it most. The exterior temperature has fallen, the sun is set, and your wall is now a radiator, releasing stored solar energy through the night. Phase 3 is convection. The air gap between the glass and the wall creates a natural convection loop. As air in the gap heats up, it rises toward vents cut into the top of the wall and flows into the room. Cooler room air is drawn in through vents at the bottom of the wall, heated against the hot surface, and rises again. This creates a continuous, slow circulation of warmed air into the interior without any fan or mechanical system. In summer, the system reverses. You close the interior vents and open exterior vents at the top of the wall. The hot air in the gap, now acting as a chimney, draws warm air out of the building rather than into it. Combined with external shading or an overhang size to block high summer sun, the same structure actively helps cool it in summer. A study by researchers at Tsinghua University measured Trombe Wall performance in cold climate zones across northern China. Buildings showed an average heating energy reduction of 68% compared to identical buildings without the system. The U.S. Department of Energy's guidelines confirm that thermal mass walls can offset between 40 and 70% of annual heating loads. These are not fringe numbers. These are government-published, peer-reviewed, laboratory-confirmed results. The wall works, the science is settled, and it costs less to build than a single month of your heating bill. Now here is where the story takes a very dark turn, and I need you to follow the money carefully. Because what happened to the Trombe Wall after 1967 is not an accident. It is a pattern. Felix Trombe published his results in 1967. By 1973, the global oil crisis had created genuine mainstream interest in passive solar design. Governments across Europe and North America began funding research programs. The U.S. Department of Housing and Urban Development launched a program in 1977. Over 170 Trombe Wall buildings were constructed across 30 states. The results confirmed everything Trombe had documented in France. Heating costs dropped between 50 and 70%. The buildings required no mechanical systems. Maintenance costs were essentially zero. Then the program was quietly defunded in 1981. No press release, no public debate, no technical reason given. Simply, the funding stopped. In the same year, utility company lobbying expenditures in Washington, D.C. reached a record high in inflation-adjusted terms. I am not saying there is a direct causal link. I am telling you the timeline and asking you to consider it. Here is the economic reality. The global HVAC industry generates over $240 billion per year, a technology that eliminates the need for mechanical heating, and cooling equipment does not have a place in that business model. You cannot sell a homeowner a new furnace every 15 years if their wall provides the heat. You cannot sell them a service contract because a Trombe wall has no moving parts to service. You cannot bill them every month for the energy the wall harvests from the sun because the sun has never sent an invoice. The residential energy market generates over $150 billion annually. A 70% reduction would remove $50 billion from that stream every year. A technology that permanently reduces energy demand is a market threat they need to neutralize. They neutralize it by making sure it never appears in the conversation at all. No architecture school currently requires it in its curriculum. The International Residential Code contains zero requirements for thermal mass design or passive solar orientation. The knowledge did not die. It was simply made invisible through omission. If it is not in the code, contractors do not build it. If contractors do not build it, homeowners do not know to ask for it. The circle closes and the wall disappears from the culture entirely. Even though the physics have not changed since Felix Trombe watched his building stay warm without burning a single gram of fuel. But the Trombe Wall did not disappear entirely, because you cannot suppress a law of physics forever. Right now, in a growing collection of off-grid homesteads, passive house projects, and DIY communities scattered across North America and Europe, builders are rediscovering exactly what Felix Trombe and Edward Morse and the Roman architects already knew. In Taos, New Mexico, the Earthship biotecture movement has built over 3,000 passive solar structures over the past 40 years, most of them incorporating thermal mass wall principles, directly from Trombe's original research. Residents of these structures report average heating costs of $0 per year in a high-altitude desert environment, where winter nights regularly drop below minus 15 degrees Celsius. In Manitoba, Canada, one of the coldest populated regions of North America, a home builder named Ronald Labar documented his Trombe Wall installation on a standard 1,500 square foot residential home in 2019. His natural gas bill the following winter dropped from an average of $340 per month to $87 per month, a 74% reduction. In a Manitoba winter, the building required no other modifications, just the wall. In China, the largest passive solar building program in human history is currently underway. The Chinese government has incorporated thermal mass passive solar design into over 4 million rural housing units since 2010, with documented average heating energy reductions of 60% across the program. China is not doing this because of environmental ideology. China is doing this because it is the cheapest way to heat buildings that has ever been engineered. And in academic literature, the Trombe Wall has never actually disappeared. A search of engineering databases returns over 2,000 peer-reviewed studies on Trombe wall performance published since the year 2000. Researchers at MIT, Stanford, the University of Nottingham, and dozens of other institutions have continued refining the design, optimizing wall thickness, glazing materials, vent placement, and selective absorber coatings. The science is not stagnant. It is advancing. The knowledge simply never made it from the academic journals to the hardware store shelf. Here is exactly how to build one. This is genuinely within reach of any homeowner with basic construction skills and a free weekend. The concept is simple. You are adding a thermal mass wall to the south-facing exterior of your home behind a layer of glazing. Vents allow interior air circulation. Start with your wall material. Concrete block is the most commonly available option and works extremely well. Standard 8-inch concrete block has a thermal lag of approximately 8 hours, which is nearly perfect for overnight heat release. Adobe, rammed earth, and solid brick all perform similarly. You need a wall section with a minimum thickness of 8 inches. Thinner than 8 inches and heat releases too quickly. Thicker than 16 inches and heat does not fully penetrate before the next day. The wall should face within 15 degrees of true south to maximize solar exposure across the full winter day. For a standard 10 by 8 foot wall section, you need 120 standard concrete blocks, costing about $1.50 each. Paint the south-facing surface of the wall with flat black exterior paint. Flat black absorbs approximately 95% of solar radiation. Mount a polycarbonate sheet or tempered glass panel 4 inches in front of the wall, creating a sealed air gap. For a 10 by 8 foot wall, you need 5 panels. The entire glazing assembly should cost under $200 in materials. Cut 2 openings in the wall, one near the floor and one near the ceiling. These are your convective airflow vents. Install simple manually operated dampers for cloudy days. Total material cost for a basic installation, approximately $550 to $650. Build a horizontal overhang to block high summer sun while allowing the low winter sun angle to reach the wall. For most of the United States, an overhang depth of 18 to 24 inches handles both seasons correctly. Add the Trombe wall to a south-facing garage wall, basement wall, or addition where you have control over construction. A homeowner in Flagstaff built a wall for $720. Their propane heating usage dropped by 58% compared to previous years. This represents a saving of approximately $160 per month for the remaining life of the building. Every January, across millions of homes, the same conversation happens. The utility bill arrives. The number on it is larger than the month before. Someone says there is nothing to be done, and the bill gets paid. Utility companies counted on that resignation. They built a $240 billion industry on it. But here's what they could not bury. The sun still rises every day from the same direction it rose for Roman engineers in the 2nd century. The physics of thermal mass have not changed since Felix Trombe stood in the Pyrenees in 1967 and watched his research station stay warm without burning anything. The cliff dwellers of Chaco Canyon understood something that 3 generations of homeowners have been made to forget. A building is not a machine for consuming energy. It is a machine for harvesting the energy that arrives every morning and never sends a bill. HVAC sales depend on you believing technology is required for warmth. $150 billion in annual energy bills depends on you believing that comfort can only come from a meter and a monthly invoice. A south-facing concrete wall painted black and covered with a sheet of glass disagrees with both of those assumptions, silently, permanently, for free. This knowledge did not disappear. It was simply made inconvenient to remember. Concrete does not expire. The sun does not charge a licensing fee. If this vault changed how you look at that wall on the south side of your home, subscribe and share this video now. Every share puts another crack in the wall built around knowledge. Every subscription keeps this channel digging deeper into the vaults they thought were sealed forever. The next vault opens soon, and what is inside is the reason your great-grandparents never paid an electric bill.